You've made it to segment 4 of 5 of this MLC experience, and this time we're going to focus a little bit more on mathematical content knowledge specifically. So first, let me just run you through what I mean when I talk about big ideas. There are big ideas in mathematics that I think are invaluable for our students to learn. What do we mean by an idea? An idea is something that has context and meaning, is generalizable, and has the potential of being foundational for other ideas and ways of thinking. And I will share later some specific big ideas that we teach, especially in the K-8 world. Ideas are ways of thinking that can generate or motivate the procedures that have traditionally been the center of instruction. So these are not the procedures themselves, these are the ideas that motivate the procedures. There was a report done in 2001 that says, when only the rules and procedures one is taught are not conceptually anchored. And remember, the math teaching practices says that these procedures should emerge from conceptual understanding, and here might be why. When rules and procedures one is taught are not conceptually anchored, memorization must pass for understanding, and mathematics becomes, to a student at least, an endless, senseless parade of disparate facts, definitions, and procedures, and that's what we want to avoid. So some ideas that I think are foundational for other things in elementary mathematics are place value, the idea of fraction. I'm not talking about adding, subtracting, multiplying, and dividing them. I'm just talking about what a fraction is. Additive reasoning, multiplicative reasoning, proportional reasoning. Those are just a select few, but on the other side, just pure procedures. If all we do is ask students to compute, we might say as a procedure the idea, not the idea, but the topic of computing, solving, simplifying, substituting, using formulas. Notice the verb nature of those procedures versus the noun version of these ideas. And I claim that if you know what it, whatever it is, means, then you will know what to do. The doing will come from the meaning of these ideas. So for example, here is one that I hope will permeate your thinking in terms of what I mean by ideas. What if I told you this? Of the 295 U.S. cities with 100,000 people or more, the average population is 292,146 people. What does it mean to say that the average population is 292,146 people? I'm going to encourage you to just pause right here, talk to your team about what this means, and then come back and listen to what I have to say. So assuming you've paused and talked, I've done this with many groups, and typically here's what I hear. The average population is, well, that's when you took all the populations, added them together, and divided by how many populations there were, and you got 292,146. Well, that's true in terms of how you compute the average city population, but that doesn't tell you what that number means. It just tells you how to get the number. I want to push you to think not how to compute the number, but what does that number actually mean? Then sometimes people say, well, you see, it's the typical population. Well, I don't know. Sometimes when you compute an average, what you get is not typical at all. There may not be a single city in the United States that has exactly 292,146 people. And so to say that that number is typical is not really true. Or sometimes they say it's representative of the 295 cities of 100,000 people or more. Well, what does it even mean to say that? It's representative. How is it representative? What does that really mean? Or it's kind of in the middle. The average is kind of in the middle. Well, you know, really, there are several kinds of averages. There's a mean, there's a median, and there's a mode. The median already is used to represent the middle. The mode is the most common, the most frequently seen, in this case, city population. But what I'm really asking about here, the context of this is not median and mode, but average in the sense of the mean, the arithmetic mean. What does that number actually mean? What does it mean to say? So when we talk about typical, there's this idea of the median. So here's teacher salaries that I found on a report on the internet. So this is median. Literally, if you took every teacher's salary, lined them up from the lowest to the highest, and pick the number in the middle. So half or above, half or below. So notice the median salary for elementary school teachers is $39,361. That number is in the middle. Half of the teachers make less, half of the teachers make more. Or there's this idea of typical in the sense of mode, the most frequent. And to highlight that idea, I'd like to show you this map. If you're like me, you may have come to Arizona from other space. I came from northern Minnesota. There's my county right there. And in northern Minnesota, if you wanted to have a carbonated beverage with lots of sugar in it, you would ask for a pop. Now, I came to Arizona, and they didn't know what I was talking about. They said, oh, would you like a soda? And if you come from the deep south, they don't call it pop or soda. They call it Coke. Everything's Coke. What kind of Coke would you like? Oh, I'd like to have a 7-Up, please. They call everything Coke. And so depending on where you come from, that's what they call it. This is an example of what we would call mode, the most common thing that you would hear. But that's not what I'm talking about in any of these things. I'm talking about average in the sense of the mean. So here's another case. The average home price tops $264,000. What I'd like you to imagine is this. If we took every home value in this region, in the U.S., I guess in this case, we took every home value and took those dollars that those homes were worth and piled them up. That's like adding together all of the values. And then equally distribute that money so that every home value was the same. Every home would have a price of $264,000. That's what average really means. So think about how you compute it. When you add up all the numbers, what you're really doing is combining all these home values into one big pile. When you divide by how many homes there are, what you're really doing is equally distributing that money, so to speak, so that each home value gets the same amount. So let's go back to our populations. If we took the population of all 295 U.S. cities that we're talking about here, and we combined all those people into one big pile, that is, we added up all the populations, and then we equally distribute that number of people so that every city got the same number of people, that number would be 292,146. That's what average means. It's this hypothetical number. I like to say it's as if. It's as if every city in the U.S. had the same population. If it did, that population would need to be 292,146, so that the combined sum of all the people would be what it needs to be, what it really is in this case of 285 U.S. cities. So when we think about that, when we think about what average means, how we compute it just follows. Let me give you a couple more examples. Any sports fans? Larry Fitzgerald. Last season, he averaged about 8.1 touchdowns, or over his career, he averaged 8.1 touchdowns per season. 8.1 touchdowns? See, that's what I mean by it's not typical. It's impossible to get 8.1 touchdowns in a season. It's not common. It's not representative. How could 8.1 be representative? Because it's impossible to get 8.1 touchdowns in a season. So what does it mean? It means this. It's as if he scored 8.1 touchdowns in each of his 11 seasons. If you equally distributed all the touchdowns he scored, that is, if you took the sum of all the touchdowns, if you add them up, he has scored 89 touchdowns in his career over 11 seasons. Take those 89 touchdowns and equally distribute them into each season bin, if you will. Each bin would get 8.1 touchdowns. If he scored 8.1 touchdowns each season for 11 seasons, he would have a total of 89 touchdowns. So that's all it means. Why do we have it? Well, so we can compare. We can compare Larry Fitzgerald against somebody else who maybe didn't play 11 seasons. Maybe somebody who played 3 seasons or 22 seasons. Now we can compare and say, if they scored the same number of touchdowns per season, how many would that be? Now we can make a comparison of Larry Fitzgerald and other players in the NFL. What about average temperature? There's a picture of my hometown of Coleraine, Minnesota, and there's the temperatures chart for my hometown. And believe it or not, in January, the average low temperature is 5 below zero. What does that mean? Well, it's as if, there's that phrase, it's as if the temperature was 5 below zero every day of the month in January, the low temperature. If you took all the temperatures in January and added them up and then equally distributed them among the 31 days of January, it would be as if every day got minus 5 degrees as a low temperature. And by the way, whenever they talk about temperatures, it's usually over a 30-year average. So with all of that examples, from populations of cities to Larry Fitzgerald to temperatures to salaries, I would like you to practice thinking about how to explain what we mean by average or the mean. So here's 2 situations I would like you to talk about and post your answers to. It has been reported, I found this on the internet, so it must be true, that the average class size for teachers in self-contained elementary classrooms in Arizona is 23.6 students. What does it mean to say that the average class size is 23.6 students? Or the Census Bureau reports that the average household size in Arizona is 2.63 people. What does it mean to say that the average household size in Arizona is 2.63 people? Will you please talk to your team and then record your responses on the online forum? And then you can move on to the final segment, segment number 5. Thank you.